Hi. So one of my students came up to me and asked me how to do this problem right over here. It's through this book right over here, Calculus. It's the 6E by James Stewart. And this is a common book that comes out quite a bit on most of the high schools across the United States. So this is chapter 2, section 1, problem number 1, on page 87. Let me write this down. Page 87. And the question is, a tank holds 1,000 gallons of water, which drains from the bottom of the tank in half an hour. So in 30 minutes. So this is in minutes right over here. The valve of the table shows the values of the table show the volume of the water remaining in the tank in gallons after t minutes. So t is in minutes, and the volume is in gallons, okay? And they already give you that information, this table below. So you notice something about this table right over here is intervals of 5 minutes. So they actually didn't give you the first value. It should have actually been 0, and this value should have been 1,000. Okay? So as you can see, it starts off at t equals 0. You have 1,000 gallons. After 5 minutes, 694 gallons. After 10 minutes, 444 gallons. I actually did some calculations ahead of time just to get to give you some information. So from 1,000 to 694 gallons in the first 5 minutes is 306 gallons that was poured out through the bottom of the valve. Okay. And then from 694 to 444 is 250 gallons. And then from 444 to 250 is 194 gallons every 5 minutes. And then from 250 to 1111 is 139 gallons. And 111 to 28 gallons is 83 gallons. And the difference is obviously 28 gallons here. So every 5 minutes, you're losing this much amount of gallons. Well, as you can see from the numbers here below, you start to lose a lot of gallons first, and then you start to lose less and less. And that's because usually due to pressure. And the pressure will always be dependent on only one variable, which is the height of the tank. So let's actually draw this out if you can. At t equals 0 is 1,000, so it's located right over here. At 0 is 1,000. At 5, I took the interval of 5 seconds, 1, 5, 10, 15, 20, 25, 30. So at the 30-minute mark right over there, time is of the independent variable, and the volume that it holds is the dependent variable. So at 0 seconds, my volume is going to start off at 1,000 gallons in this tank. And then after about 5 minutes, you have 694, which is a little bit less than 700, so it's going to be something like this. At 10 minutes, 5 more minutes after that, it's going to be less than 500. So it's going to look something like this. And then at 250 gallons, 15 minutes is going to be 250 gallons, which is about halfway. That. At 20 seconds, it's going to be 111. So it's going to be like right over here somewhere. And then at 25 minutes, it's going to be 28 gallons. It's going to be very close to 0. And finally, it's going to be 0 gallons at 30 minutes. So let's actually draw this out if you can on a piece of paper. We're just going to connect the dots here. And something like that. Okay. And this is the way, most drains go about when the drain is at the bottom of the tank. The first question asked is, if P is a point 15, 250, so they give you a point which is 15, 250 on the graph of V, here's a function V, find the slope of the secant line PQ. So the first keyword is secant line versus tangent line. So what's a secant line versus a tangent line? When you have something like this, if it goes through 2 points, that is called a secant line. And if it goes through just 1 point, and it's tangent to it basically, That means it can only go through one point right here, not this way, but it has to go in such a way that it cannot go through the 2 points right here. This is called a tangent line. This is very important. Secant line goes through 2 points. Tangent line only goes through 1 point. Okay, so make sure you get these two down. They will be on your AP exams. Okay. So for part A, if P is a point 15, 250 on the graph of V, find the slopes of the secant line PQ, where Q is a point on the graph with T equals 5, 10, 20, 25, and 30. So what are you looking for? The slopes of the secant line. What letter do we use for the slope? Well, we still use the same slope formula from 8th grade. M we use for slope. We use subscript secant. And the slope for the secant is change in y over change in x. The vertical distance, the rise over the run. It's the same exact formula. Okay. So you have to do maybe 1, 2, 3, 4, 5. 5 of these secant lines. So at t equals 5, they give it to you, and the volume is 694. Excuse me, 694. So we have to find the slope of that. Change in y is the volume right over here. So 5, 10, 15. At the 15-minute mark right over here, you're going to try to find this slope right there. Okay. And it's going to be rise, the change in the y value, which is, I did it for you, 694. 694 minus 250, that's the change in the y, or change in the volume. And then the change in time is 5 minus 10. And you end up with 694 minus 250 is going to be 444 over 10, which is negative, of course. Right over here, it's going to be negative 44.4. The units are volume, which is gallons per minute. It's losing 44 gallons per minute, okay, at this stage. At t equals 10, it's the same process. It's going to be, your point P is going to be 15, 250. Your Q is going to be 10, 444. So it's the slope secant is equal to 444 minus, let me see, 250. Y2 minus Y1 over 10 minus 15. And you're going to end up with negative 38.8 gallons per minute. You notice a little bit of difference. You're losing a lot of gallons per minute during the first 5 minutes, but you're losing less gallons per minute as time wears on. As time wears on, from 5 to 10, excuse me, slope's going to be a little bit different. And I did 3 of them for you. So let's do the second page right over here. P is 15, 250. Point Q is going to be at 20 minutes. It's going to be 111 gallons left. The slope of the secant is equal to 111 minus 250. Changing the y over changing the x. 20 minus 15 is equal to negative 139 over 5, which is approximately negative 27.8 gallons per minute. I actually verified all of these numbers in the back of the book, so I'm pretty sure I got them right. And that's it. And you could do all the rest for 25, etc., for 25 and 30 as well at t equals. Okay, so you have 2 more to do. Let's do part B now. It's a little bit less tricky. So what happens is this: at 15, and then 20, and then I'm going to exaggerate a little bit, at 10. So I'm going to find this slope and then find this slope, and then try to figure out what the average of these two slopes are. And the way I did that is at 10, this is at 10 seconds, right? Find this slope, which was 38.8 negative, and the other one to 20, right over here. The slope was negative 27.8. And how to find the average of that? Negative 38.8 plus negative 27.8 divided by 2, that's your average, which turns out to be negative 33.3 gallons per minute. And so you can actually do the secant, the average of the two slopes here. Part C, this is the way they want you to do this on the AP exam, okay? To find the tangent slope of this right here, like that, if you want to find the tangent slope of this, what you could do is take one before, take one average, and you can try to look at the secant slope, and it should be very close to the tangent slope. This is actually the way they want you to do it. So you take, so since this value is 15, right? Take the one before it, which is 10. Take the one after it, which is 20. So you're going to be finding the secant slope between 10 and 20. And I did it for you for part C. So it's going to be, at 10, it's going to be 444. And at 20, it's going to be 111. So our answer is going to be the slope of the secant, which is approximately the slope of the tangent, is equal to 444 minus 111. That's the change in the y over change in the x, which is 20 minus 10. That turns out to be 333 over 10, which is approximately 33.3 gallons per minute. They do not want you to do it this way, averaging the two secant slope. They would rather have you average the one before and the one after from your starting point to get that secant or the tangent line. So the tangent line is pretty approximately close to the secant line located here. Hope it helps. Good luck on your homework for Chapter 2.